Here we have a cell notation with a list of species. We have a list of species that we need to identify which one is the strongest reducing agent and the strongest oxidizing agent. In this case, the strongest oxidizing agent is my dichromate ions and my hydrogen plus ions. The strongest oxidizing agent is the cathode. For this half cell, I need to write down my dichromate and hydrogen ions in one container. Now, since this is my oxidizing agent and this represents my cathode side, neither the dichromate nor the hydrogen protons have a solid counterpart. I need a solid electrode. In this case, carbon is sufficient to be my inert electrode. This is my cathode side, the half reaction. Next, we have to identify our strongest reducing agent. In this case, the strongest reducing agent is my iron 2 plus. Our strongest reducing agent is our anode. So we place the iron 2 plus on the other half cell. Note that we don't have any solid iron. Therefore, we need to also use an inert electrode. In this case, carbon again for my anode. We can't assume that this will be an iron solid because iron solid was not given in the notation. Therefore, we needed to find an inert electrode, as I said before, and this carbon is sufficient again. I could have chosen platinum. Either one would work. The anode side is where oxidation happens, meaning that the iron 2 plus will lose electrons. The loss of electrons by Fe2 plus will produce iron 3 plus. The loss of electrons means that the electrons has to move somewhere. The electrons will move from the anode to the cathode. As more electrons is being lost by Fe2 plus, there will be less Fe2 plus and more iron 3 plus in the solution. The electrons are moving to the cathode. Remember that carbon does not interact with the electrons, it's inert. The electrons then go into the solution and meets up with our oxidizing agents. These oxidizing agents are undergoing reduction, meaning that this dichromate and proton will now produce a new product, chromate 3 ions and water liquid. As the electrons keep moving to this side of our half cell, there will be less and less dichromate and hydrogen protons. There will be more and more chromium 3 ions and water being produced on this side. To represent what's happening in the diagrams, we can write our half reactions. So the cathode is undergoing a reduction. The anode is undergoing an oxidation. The reduction half reaction is as written from page 7. The oxidation half reaction is reversed from page 7. Note that we need to balance the number of electrons gained to the number of electrons lost. Our final redox reaction is as follows. Notice that all of our products are aqueous or liquid. Therefore, from our reaction, we will not be able to see any visual evidence that the reaction has taken place. For example, there will be no buildup of new material, no solid precipitates. Therefore, the only evidence that the reaction is happening is if we had an ammeter here or a light bulb to note that the electric circuit has been completed. We can adjust our original cell notation by including our products. Note that in the original cell notation, we already have a product in with iron 3 plus, but we can adjust it by having chromium ions and water in the other half cell as products in blue.